Okay, and the fun isn't over yet with standing waves in pipes, because there are more good things that can happen. Because now what I'm going to do is take the pipe we had earlier and I'm going to close one end. Okay, that means the air at this end can't move. So this is still going to be an antinode at the open end, if I can spell it. Okay, but now this air, oh, it has got an E on it, I promise you. This air at this end can't move, so we've got a node. So that changes completely the kinds of shapes we can get. So I'm going to start in the middle here, because as before I'm going to draw transverse waves to show these things going on. Okay, so from my node here I'm going to go to an antinode. Okay, and the easiest way to do that is just to go up and reach it. Okay, with a dotty one down there. Okay, so the air at this end is going backwards and forwards like mad. This is standing still. What's my wavelength in relation to my length of my tube? Well, the length of the tube is now a quarter of a lambda. Okay, because remember, the distance from a node to the next node would be half a wavelength, but I've only got half that distance because I've only gone as far as the next antinode. So that means the lambda is 4 times the length of the pipe. Okay, which is great. And then v, if v is the speed of sound, again, then my frequency, well, remember v equals f lambda. Okay, so frequency is going to be v divided by lambda. Okay, which will be the speed of sound divided by lambda is 4L. Okay. All right, so that's again my fundamental. Now notice that when I had the pipe open at both ends, I had to go all the way from an antinode to another antinode. Okay, so that was a whole half of a wavelength. Okay, which means that for the one I did before, L was half lambda, so lambda was only 2 times the length of a pipe. So now I've got 4 times the length of the pipe as my wavelength, so the wavelength is twice as big, which means my frequency is going to be half as big. Okay, so that's why a pipe that's closed off at one end, okay, when you set up its fundamental frequency, it's an octave lower. It's a lower frequency than the pipe that's open at both ends. So we've explained that. It's because we've got a lambda that's 4 times the length of the pipe instead of a wavelength that's only twice the length of the pipe, lower note. Okay, now let's think about the next harmonic. Okay, how can we get a higher frequency in this tube? Well, we've still got to go from this node to an antinode. Okay, but instead of having an up antinode, let's make this a down antinode, and let's start by going up first. So what that means is we're going to have to change colour. We're going to have to go to another antinode beforehand. So I've got to visit an antinode up here, and then I've got to come down and have the antinode down there. Okay, well, that'll do. Okay, and you'll see that I have to go via another node here, and that I've got an antinode there, and I'll draw the sort of upside down one as well. Okay, so this is staying still, this is staying still, the air like here is vibrating like mad. Okay, actually this way, though I've drawn it like it goes that way, and this air is vibrating like mad, antinode. Okay, so what's the length of the pipe now? What's my L in terms of the wavelength? Well, my L, okay, is now how many wavelengths? Well, from a node to an antinode is a quarter of a wavelength, so I've got 1, 2, 3 of those quarter wavelength distances. So L is now 3/4 of lambda. Okay, so L of course is fixed. So if that's 3/4 of lambda, the wavelength for this blue wave, okay, it's actually only 1/3 as big as the wavelength was before. Okay, I could solve this equation. Okay, let's do that. So lambda equals, okay, divide by 3/4, that's 4/3. Okay, and so lambda is 4/3 of the length of the pipe. Okay, which is only 1/3 as big as before. Okay, so if lambda is 1/3 as big, f is still, the frequency is still v divided by lambda. But if lambda is only 1/3 of what it was, okay, then the frequency, if I call this f0, the fundamental frequency, then the frequency of this particular harmonic is going to be 3 times as big as that f0, because if the wavelength's only a third as big, the frequency is 3 times as big. I can even do it with the numbers here, if you like maths. Okay, I can say that I can put this into f equals v over lambda. Okay, and so that's v, speed of sound, over lambda is 4/3 of L. Okay, and I've got a horrible fraction within a fraction, so I'd have to multiply the top and the bottom by 3 to get 3v over 4L, and then I can compare it with what I got for the fundamental frequency and see, okay, it's identical except for this 3's appeared, so it's 3 times as big, which is what I said to begin with, if only you'd believed me. Okay, when we're fitting 3 quarter wavelengths into the tube, we've got only a third of the wavelength and therefore 3 times the frequency. So there isn't a harmonic with a 2f0. The next harmonic after the fundamental frequency in a closed-ended pipe, okay, is 3 times the frequency. Okay, and the next one after that, well, let's just draw one more. Okay, so I've got to go a node here. I'm going to go back to an antinode that's on the up here, a bit like that first black one that you can still just about see. Okay, but I'm now going to get an up antinode, and bang in the middle of the pipe a down antinode. Not back up bang in the middle of the pipe. That was a lie. And then up to this up antinode. I've drawn that a bit wrong. That one will be a little bit further along. Okay, because it's not symmetrical, is it? We're starting with a node, we're ending with an antinode, so we're going to get that. Okay, so now that is an antinode, that's a node, that's an antinode, that's a node, that's an antinode. Okay, so how many quarter wavelengths have I got? Remember, well, I can see a whole wavelength now, but it's divided. That's one wavelength away. These points are in phase, these points are in phase. But if I look at from a node to an antinode, quarter of a wavelength, remember, I've got 1, 2, 3, 4, 5 of those gaps. So I've now got, well, if I think about the length of the pipe will now be L, which you can't see down there, but never mind. L equals now 5 quarter wavelengths, 5 over 4 times lambda. Okay, which means that the wavelength of the green one, the lambda, okay, will be compared with the original lambda of the black one, it will only be a fifth as big. Okay, so lambda will be a fifth as big as before, so the next frequency, f, will be 5 times as big as that fundamental frequency. Okay, and I won't go through all the maths at this stage, but you should be able to. And that shows that in a closed-ended pipe, okay, you get a basic frequency, the next harmonic has got 3 times the frequency, the next one has got 5 times the frequency, so it's all going to be odd multiples of that basic frequency. And you get that in a closed-ended pipe, but not in the open-ended pipe that we saw before. Isn't that great?